Chapter 7, Part 2, Day 3. Alright, so more conditional probability. In the previous lesson, you were given the counts or frequency of the number of people or objects in a given situation. And then from this, you computed conditional probabilities. In this lesson, you will extend your understanding of conditional probabilities by starting from probabilities rather than counts. You will investigate the association of two categorical events. So build a farm. In the children's game Build a Farm, each player first spins a spinner. Half of the spinner is red and half of the spinner is blue. If the spinner lands on red, the player reaches into the red box. If the spinner lands on blue, the player reaches into the blue box. The red box has 10 chicken counters, 10 pig counters, and 10 cow counters. While the blue box has 5 chicken counters, 4 pig counters, and 1 cow counter. So you can see the odds are here of red or blue spinners, and then in the bag what counter you're going to get. So it says draw a tree diagram including probabilities to represent the sample space for each game. So let me go ahead and make a little bit of room here. So again, hopefully we feel pretty comfortable with how to do this. We've definitely done this before. So first thing we're going to have is a spinner where it's either going to be blue or it's going to be red, and those are 50-50 odds. From there, if it is blue, I guess I'm down here, I get a chicken half the time, I get a pig 2/5 of the time, and I get a cow 1/10 of the time. If it's red, I'm gonna get a chicken 1/3 of the time, a pig 1/3 of the time, and a cow. I guess I'll put CO for cow 1/3 of the time. My preference always is to have like a common denominator. So I'm looking for a number that 2, 5, 10, and 3 all go into, and I think that number is 30. I just think it's easier to have a common denominator. So I'm going to put all these in terms of like 30. So this would be 15 out of 30. This would be 12 out of 30. And this would be 3 out of 30. And again, you don't have to do this. It's just my personal preference to make sure that these all work out the same, and then these would obviously just be 10 out of 30. So if I multiply the odds here, the odds of getting a blue chicken are going to be 15 out of 60. The odds of getting a blue pig are going to be 12 out of 60. A blue cow are going to be 3 out of 60, and you can see this should add up to 30, right? So that's 27, 30 out of 60. Over here, I'm going to get 10 out of 60, 10 out of 60, and 10 out of 60. So if I add all these up, it's going to equal 60 out of 60. So I just think it's easier to have like common denominators to an equal comparison. I know that the most likely thing I'm going to get is a blue chicken, and the least likely thing I'm going to get is a blue cow. And this picture would show that to be true. All right, so what's the probability of getting a cow counter in one turn? Well, there are 3 blue cows and 10 red cows, so I would say 13 out of 60. Well, proportionally, there's that many, right? I mean, there's not really that many, but that's the probability of this. You can also use a modified area model as shown at right to represent the sample space. So copy the area model and shade the parts of the diagram that correspond to getting a cow counter. So there we go. There's our cow counter right there. And again, that one right there is a 1 in 20 chance, and that one right there is a 1 in 6 chance. So if you get your common denominator, you're going to see that it's going to add up to be 13 out of 60. So it says if you know a player got a cow counter, so they got a cow, what's the probability that they originally spend red? Well, the odds look better, right? I know right now that I'm just saying there's 13 cows here, right? And 10 of those 13 are reds. Again, this is all proportionally. There's not really 13 cow counters, but when I get a common denominator, there are. Now it says, are the events of red and cow independent? I would say no, because you can get a, I'm sorry, red and cow independent. So let's see here. So first of all, what are the odds you get a red? It's 1 in 2 for 50%. And now, given that someone had a cow, what are the odds that it's red, right? So 10 divided by 13 is going to be 77%. So we would say, yeah, there is an association here. You're more likely to get a cow if you got red first. All right, so what's the conditional probability that if you got a pig counter, your spin was blue? Well, if I got a pig, now I'm looking at this one. So there's a 12 out of 60 here and a 10 out of 60 here. So there's 22 ways I'm going to get a pig. And 12 of those 22 are blue. So hopefully that makes sense. Alrighty. Let's go ahead and do 781 and then we will be done for today. Conducting a survey for the school news blog. He surveys 200 senior students. So now we actually have to make our own table, right? So hopefully we're going to use some of that stuff that we talked about. 200 students, that's the total. And 78 had access to a car on weekends. It doesn't say anything about having chores, so that must be a total. 54 have chores assigned at home, but it doesn't say anything about a car, so that must be a total. And then 80 have neither access to a car nor chores. So that mentions both, so that can go in the middle. So that's going to go right there. And again, where we need to start is where there's one unknown. Here there's two unknowns. We can't start there. We're going to start here. So this would have to be 146, which would make this one equal to 66, which would make this equal to 12, and this equal to 42, and this equal to 122. And again, I would tell you to add sideways. 12 plus 42, 66 plus 80, 78 plus 122, and then up and down as well. And that way, if you have an error, you should catch it. So, all right, so we have our two-way table done. And now it says that two-way tables often include row and column totals. Add row and column totals to your two-way table. We already did. Is there an association between car privileges and having regular chores? So what we'll do is just say, hey, everyone, we'll just ask, do you have chores? And we'll see what they say. So 54 out of 200 have chores. So 27% of people have chores. And then what we'll say is, given a car, do you have chores? All right, so we'll ask everybody, you have chores, and then we'll just ask the people with a car, do you have chores? And in this case, it's 12 out of 78. So we will go here and say 12 divided by 78 is 15%. So those numbers are different. So we would say, yes, there's an association. For whatever reason, people that have access to a car do not seem to have to do chores. People that don't have access to a car do seem to have to do chores. So I guess that's a little bit of the Cinderella syndrome right there.